All right, so Unit 4.4 jumps into logarithmic functions, and kind of a quick little background on logarithmic functions is that logarithmic functions were created to solve exponential functions. And so just as a quick little side note to kind of to see why this happens and what we're going to use it for, you know, if we have two, let me back up. If we have the number 8, 8's neat because it's 2 to the 3rd power. If we have the number 16, 16 is great because that's 2 to the 4th power. And we can keep on going. We can say 2 to the 5th power is 32, and we can say 2 to the 6th power is 64, etc., etc., etc. And we can back up and we can say 2 squared is equal to 4 also. But what about if we came in here and said, okay, well, I want to find 10. I want to find out 2 to what power equals 10. And so, you know, obviously we can see there's going to be somewhere between 3 and 4, right? Because, I mean, 10 is between 8 and 16. But is it going to be 2.5? Is it going to be 2.4? Like, what would be the exact value? And so logarithms were created to allow us to solve this situation. They were allowed us to take something that's an exponential form, convert it to log form, and I'm going to go ahead and even though I haven't explained, I'm going to do the process. Convert it to log form. This becomes log base 2 of 10 is equal to x. And then at that point, we have the ability to solve that logarithm. In the past, we had what was called a log table. We have formulas that you know allow us to do what's called a change of base, which we'll get into in the next section. And then, but now we have graphing calculators, or we have calculators that have the capabilities of solving this logarithm because they have the formula or the recipe that you need plugged into the calculator. So you just plug it in, it tells you the answer. So, but that was why we had logarithms. So with that said, let's move forward. Oops. Or how about backwards? So let's move backwards and talk about the parts of an equation. So first of all is exponential functions, which is unit 4.3. And log functions, which is unit 4.4, they are inverses of each other. They are opposites of each other. So when we think about graphs, we're going to think about this relationship as being opposite. Let's identify the parts to each one. So an exponential function, we know that b is the base, x is the exponent, y is the solution. And a log function, we convert this around, and you saw me draw the arrows already. The way we convert them, which we're going to talk about in just a minute, is we start at the base, we go towards the equal sign, and we swing back around. So you can see, here's my base. So log base b of y equals my x. So that's the conversion piece there. Now, in this case here, to be actually find the inverse of that equation, we would switch our x and our y, but that'll be good enough for what we're talking about right now. Okay. So with that said, let's take a look at a few examples. Let's take a look at some examples right here that these guys are in log form. And what we want to do is we want to convert. We want to practice taking stuff from log form and putting it into exponential form. All right, so taking that a little bit of information from the previous page, let me pause for a second. Okay, so taking that stuff from the previous page, we know that we have an exponential form. It's y equals b raised to the x. This goes back and forth, goes either way. When we do it in log form, it would be log base b, that's a subscript, right? So it's a little bit lower down, of y is equal to x. So remember, in Microsoft Word, you have subscripts and you have superscripts, right? So x is a superscript, b is a subscript. So make sure you make that delineation that's down below. All right. Remember to do this, we start at the base, we go towards the equal sign, we swing around to the exponent, or vice versa. If I'm going from log form to exponential form, I start at the base again, I go towards the equal sign, and I swing around. So when I go here, and I really recommend that you write this down. You don't need the word if and then, just the problem itself. I really recommend that you draw the arrows. So start at the base, go towards the equal sign, swing back around. So this guy in exponential form would be 3 to the y equals x. Okay, remember we don't need the words, we just need the example. But go ahead and hit pause, do these next three, and then compare your answers with mine. So you start at the base, you swing around, come to 81. So this is 3 to the 4th is equal to 81. Start at the base, swing around towards the equal sign, come back around. Remember the key thing is go towards the equal sign. So 5 to the y is equal to x. And the last one, start at the base, go towards the equal sign, swing back around. So that's 5 to the negative 1 is equal to 1/5. Now, what you're going to see about this slide is that, this guy right here makes no sense. It's not a problem. It's not something we can solve. This is a true statement. Like, that's a true statement. It's actually got all numerical values. We can actually solve it. You can see it. Here, once again, this makes no sense. And then same thing here. This is a true statement. And so I'm going to come back to fill in why I made that point in just a moment. Let's go the other way. So now I've got three of them that are in exponential form, and I want to put them into logarithmic form. So these are in exponential form, and I want to go to log form. Okay, so same process. Let's cheat real quick. Let's grab a snapshot of what we've written right here. We'll bring that onto our page. Sound effects are important, right? Okay. Put that right there on top of that. Okay, I just like my own drawing a little bit better than looking at something typed up. So the process is we start at the base. So it will be log. We start at the base, b. We go towards the equal sign, and we swing back around. So that would be log base 1.2. Remember, there's a subscript of m is equal to 3. Okay, so hit pause, do the next two. So this would be log, start at the base, go towards the equal sign, swing back around. So this would be log base e of 9 is equal to b as in boy. Okay, don't get caught off by that e. I'm going to say some more stuff about that e here shortly, but don't get caught off. They're just using e as a variable in this particular example. All right, the last one. Start at the base, go towards the equal sign, and swing back around. So this would be log base a of 24 is equal to 4. Now, each one of these are not comprehensible either. I mean, in this case here, we could actually find out what m was. In this case, we could say, oh, we just take 1.2 to the third power, and we can find m. In this particular case right here, we're looking at, two variables essentially raised and getting none. That doesn't make any sense. Here, we're trying to find out what a would be equal to, and so we put it into exponential form. It didn't necessarily help us. And so we're going to look at some more strategies of what we would do at this point. But remember, my conversation was that some of these are solvable at this point, some of them are not. So let me hit pause and kind of see where I am, and I'll be right back. Okay, so we'll wrap that video up right there, and that'll just be converting from one form to the other. All right, be right back with a new video.